Thank you very much to giving us the opportunity to share our activities for industrial cybersecurity. I'm Takashi Amano, General Manager, Cybersecurity Center at Toshiba Corporation, as well as the Technology Executive and CISO at Toshiba Digital Solutions Corporation. Today, I'd like to talk about how to protect power plant and industrial infrastructure from recent cyber attacks based referring cases in Japan. Before jumping to today's topic, Japan is particularly vulnerable to natural disasters because of its climate and topography, and it has experienced countless earthquakes, typhoons, and other types of disasters. A number of factors contribute to the high incidence of natural disasters, such as subject to extreme climatic variations, seasonal rain fronts, and typhoons, and located in the Pacific earthquake belt. Therefore, Japan has built various countermeasures against disasters, such as prevention research and systems. Research activities into the scientific and technical aspects of disaster prevention, the reinforcement of the disaster prevention system, its facilities and equipment, and other preventive measures. Construction projects designed to enhance the country's ability to defend against disasters. Emergency measures and recovery operations, and the improvement of the information and communication systems. We are very conscious of the natural disaster and making a continuous effort for mitigating the risk. I believe the experiences would also work on the cybersecurity resiliency. Here is the agenda. After Toshiba's brief introduction, I'll talk about recent cyber attack, trend, and its risk. How to consider cyber resilience for power plants and industrial infrastructures. Finally, I'll show you our case. Brief introduction of Toshiba. Toshiba Group delivers products and services worldwide in energy system and solutions, infrastructure system and solutions, building solutions, retail and printing solutions, electronic devices and storage solutions, digital solutions, and battery business. Here is the example of the equipment and solutions at energy system, social infrastructure, and building. Here is the equipment and solutions at semiconductor, digital solutions, and battery system. As I mentioned, Toshiba Group operates in a wide range of fields and comprises about 20 business units all over the world. We classify these businesses into 4 functional segments. First one, device products, which includes semiconductors and motors. Second, infrastructure system, which covers the initial construction of essential infrastructure. Third, infrastructure services, which deals with long-term equipment maintenance and inspection, equipment renewals, and constructed operations. Fourth, data services, which collects and analyzes the very wide range data generated from infrastructure service operations and use them as the basis for value creation. As an infrastructure service company, we are building links between each segment to realize synergies that will allow us to create and deliver high value add products and services, and to cultivate new demand. This is our first step toward becoming an infrastructure service company that takes full advantage of CPS technology. In the future, the physical world of real-life events and real things and digital virtual space of the cyber world will cooperate with each other. Information from any fields will be amassed as data, processed and analyzed with AI and digital technology in cyberspace, and fed back to the physical world as information and knowledge that can be easily applied. This process, the domain of the cyber-physical system, CPS, generates add value, and it's growing at an accelerating pace. CPS technology creates a synergy loop that connects device products, infrastructure systems, infrastructure services, and data services. Since its founding as a manufacturer, Toshiba has secured extensive knowledge and achievements in a broadband range of business fields. By combining these with information processing, digital and AI technologies, we are able to make full use of CPS technology and to take on and solve the problems facing society and our customers. Beyond this, we also aim to solve social issues with our own cutting-edge technologies, such as precision medicine that allows people to lead healthier, richer lives, and quantum key distribution that realize unbreakable information transmission. Next, I'd like to show you recent cyber attack trends at industrial sector and in Japan. In the terms of cyber attack trends, the following are examples of global attack on critical infrastructure over the last decade. There have been a number of cyber attacks targeting critical infrastructure such as power plants, oil and gas, steel mills, and the automotive industry. The Stuxnet threat that targeted industrial control system in 2010 is still fresh in our minds. In 2014, a malware targeting industrial control system was distributed by defecting the ICS vendor's website and allowing customers to download it. Since around 2017, there has been an increase in attacks using malware called ransomware, which disables infected PCs by locking them up or encrypting their files and then demands a ransom in exchange for restoring them. Critical infrastructure attacks are penetrating information system network, taking advantage of vulnerabilities in products and systems to spread the infection and even affect industrial control system. In Japan, the cyber attacks have increased. As for IT security, The attack is sophisticated and attacker targets defense industry. For example, by targeted cyber attacks, manufacturing company leaked personal information. Electronic company announced that an unauthorized access to a server used by the defense business unit. And also, steel manufacturing company had unauthorized access from 2016 to 2020 for 4 years. As for product security, nowadays attackers target supply chain, as you know. Hackers attack vulnerabilities in generated software embedded in products, such as Ripple20, malicious code in OSS, and abuse software update. Control systems are also targeted in Japan. In June 2020, 2 domestic and 11 overseas automotive plants were shut down due to cyber attacks. CPS point of view, digital risk is rising exponentially. First one, the target of cyber attack is widely increasing. IT infrastructure, OT system, products, solutions, services, value chains. Second one, entering point of cyber threats, intrusion is increasing. All the target I mentioned will be the entrance of cyber threats. Third one, cyber attack methods are diversified, sophisticated, complicated. That means the unknown attacks are increasing to respond to unknown threats. We have to change and to challenge from defense to offense, from reactive to proactive. To protect power plant and industrial infrastructure from these cyber attacks, especially OT system, we have to organize or systemize the methodology of cybersecurity measures. We believe that protecting the industrial control system will ensure business continuity, in other words, cyber resilience. What is the cyber resilience? In Japan, cyber resilience refers to the mechanisms and ability to minimize the impact of systems cyber attacks and restored to its original state as soon as possible. In US, NIST defined cyber resilience is the ability to anticipate, withstand, recover from, and adapt to adverse conditions, stress, attacks, or compromises on systems that use or are enabled by cyber resources. UK defined cyber resilience is the ability to prepare for, respond, and recover from cyber attacks. So we summarized that cyber resilience is ability to prepare, mitigate the impact, and response and recover. I introduce characteristics of cyber resilience for CPS technology company. Since we cover with cyber and physical systems, our target of cyber resilience is both IT, information technology, and OT, operation technology systems. As for IT system, for example computer and server, most of them are general purpose products. These systems mainly deal with data. As for OT systems, for example, industrial control systems such as adjusting heat, pressure, and monitoring flow of the electric power, these systems are mostly customized depending on customers' request. Information security's primary focus is the protection of the confidentiality, integrity, and availability of data. To ensure these points, technical security measures are important. And also, IT security can strengthen by automation tools such as incident response. On the other hand, OT system controls the physical process, such as adjusting heat. Therefore, not only technical measures, but also operation and management measures, such as setting, procedures, are important to operate these systems safely. If control system stops in power plant, it affects of the supply of power. Therefore, during compromise, OT system need to continue operation. The scope of cyber resilience for CPS is very widely. Here is the industrial infrastructure network configuration in general. Network layer is divided 3 sections: information network, information control network, and control network. Information network layer, we have to consider information security point of view. Control network and control information network layer, we have to consider both product security and ICS security. In addition, if we consider the data service on the infrastructure services, we have to consider data security as well. We have to consider that how to manage these several security areas. This is the one of the conceptual model for cyber resilience. Horizontal axis shows the time, and vertical axis shows the system performance. This model means that once the incident occurs, the system performance is degraded. Then we do respond and recover. Finally, the system performance returns to normal. In this model, we define the period before the event as prepare. The parameter is F. The period during the event as mitigate. The parameter is I. And the period after the event as respond and recover. The parameter is R. Parameter F means the mean time between failures. Parameter I means the decrease in efficiency due to failure by the incident. Parameter R means the mean time between respond and recover. In order to minimize damage caused by the incident and continue the businesses, it is necessary to take measures to lengthen F, minimize I, and shorten R. Especially in control systems, on-site knowledge, field knowledge, is required for response and recovery. Next, I'd like to consider how to bring each parameter closer to the goal. First of all, I'd like to consider parameter F. How to longer F? As it is called cyber hygiene, it is important to keep the system healthy. IT systems are automatically updated with OS and software on a regular basis. On the other hand, the OT system is regularly maintained Ensuring security from the design stage, visualizing assets, and continuous monitoring are important. It is also important to collect logs in real time, analyze them, and accumulate them as knowledge of system operation. As a next step, strengthen deterrence and prevention measures are needed. As a general rule, the idea of defense in depth is important. But it is also important to insert the unidirectional diode at the boundary between IT and OT, and to strengthen the endpoint security of legacy devices. Maintaining system redundancy in the event of the incident is paramount. Finally, you may consider using threat intelligence to predict cyber risk. Predicting the likely attack vector leads to deterrence. Next is considering the parameter I. How to minimize I? Real-time detection of cyber attacks by anomaly detection technology and behavior detection technology using machine learning is important. An intrusion detection system that passively detects anomalies in the control system's unique protocol is effective. The SOC function that can integrate IT and OT for monitoring is also important. From another perspective, it is also effective to minimize damage by zoning the industrial control network to monitor the conduit communication and internal state of the zone. Next, I'd like to consider the parameter R. How to shorten the R? In the event of the cyber attack, IT system generally shut down the target area and try to recover from backup. On the other hand, OT system often cannot be stopped and must be restored while being compromised. At this time, if the system is divided into zones, it will be easier to recover. We can switch to the subsystem, but it requires continuous monitoring during recovery. On the other hand, in the case of restoration of control system, actually, there are many things that depend on the experience knowledge of on-site engineer. By visualizing the optimizing the response and recovery process in advance and automating using SOAR, it is possible to shorten the recovery time. As mentioned above, in order to secure cyber resilience, it is necessary to deal with three factors: prepare, mitigate, respond, and recover. As shown here, we believe that the accumulation of experience and knowledge by repeating the cycle of prepare, mitigate, response, recover will lead to strengthen cyber resilience. It is also important to work on automating each processes in this cycle and how fast this cycle can be run. This is the image of the cyber resilience operation platform that we are thinking of. To automate operations, we input logs from assets and threat intelligence into SOAR and generate SOAR playbooks with product knowledge and field operation experience. Next, I'd like to show some case study for critical infrastructure protection like power plants and industrial infrastructures. This is a typical industrial infrastructure network configuration. It shows three layers of control network, information control network, and information network. This is a case for power plant in Japan. In this case, a unidirectional data diode is inserted between the information network and the control information network to completely prevent the intrusion of threats from the information network. Unidirectional data diode also have a very limited impact on the network, which can minimize the impact on existing systems. It also has the feature of being able to securely collect data generated in the field with utilizing data as a means of realizing digital transformation of infrastructure. This solution is popular with critical infrastructure customers. This is a typical solution, maximize parameter F at cyber resilience. This is a case for National Research Institute in Japan. This solution uses a whitelist to communicate only with devices that are allowed to communicate. It solved issues that are difficult to deal with conventional methods, such as strengthening the security of legacy devices, eliminating vulnerabilities in remote maintenance, and moving confidential data at R&D division. This solution is a solution that applies the secure card technology that Toshiba has cultivated over many years and maintain high reliability. This is a typical solution, maximize parameter F at cyber resilience as well. This is a case of identifying and visualizing OT assets at power plant in Japan. This OT-IDS solution has the feature that it can automatically detect the devices connect to the network and visualize the network connection relationship in real time. This solution provides continuous monitoring and vulnerability management without affecting the operating network at all. This solution can provide, for example, the list of device, the list of vendor, file sharing, login information, system error, and so on. This is a typical solution, maximize parameter F at cyber resilience as well. Another important function of the OT-IDS solution is to analyze both unknown and known threats from the behavior of the industrial control system, detect anomalies according to the control protocol, and recommend countermeasures. It can support original protocols. It can provide prioritized alert on the dashboard, and operator can analyze the detail of the alert on the same dashboard. This solution contributes minimize parameter I and shorten the parameter R. This is an example of manufacturing industry that utilize SOAR for the purpose of visualizing risk and automating responses. Information from assets, including OT, information from MSS, threat information, are entered in SOAR, and automatically analyzed risk information is displayed centrally on the dashboard. Depending on the status of the alerts, the parameter of the security device may be updated, and instructions for responding to CCERT and PCERT may be issued. This is also minimizing the parameter I and shorten the parameter R. This is the case of electricity company in Japan. Recently, knowledgeable companies such as the manufacturing industry are providing OT SOC services. In addition to IT knowledge, control system knowledge and equipment knowledge are combined to support highly accurate threat detection and quick incident response. Power plant and industrial infrastructure, where the threat of cyber attack is increasing, can also be effective in improving functions and reducing costs by using such services when it is difficult to operate SOC in-house. In order to reduce parameter I and parameter R, the knowledge of the information security, ICS security, product security, and response capabilities for all are required. This is difficult to achieve on our own, and we believe it is necessary to work with trusted partners. Cyber resilience approach is effective in protecting critical infrastructure such as power plants and industrial infrastructure from cyber attacks. Collaborating with trusted partners with knowledge of information security, ICS security, and product security is a shortcut to that approach. Thank you very much for your kind attention.